Good morning, students. Well, to continue with the topic median, where already I've explained you how to calculate median by individual series, discrete series, and frequency distribution. So today we will be doing that if the data is been given in inclusive series, then how to find out median. Well, children, if you see, to explain you how to calculate median if the series is been given in inclusive, then the data which is been given over here is marks, which has been given as 46 to 50, 41 to 45, 36 to 40, 31 to 35, 26 to 30, 21 to 25, 16 to 20, 11 to 15. And if we see number of students, for 46 to 50 we have 5, 41 to 45 11, then 22, then 35, then 26, then 13, then 10, and for 11 to 15 we have 7. As already when I started with this median, I told you to calculate the median, either you have to put the data into an ascending order or into an descending order. So keep this thing in mind. But over here, if you see, the data is in inclusive series. So children, already I have told you before also that if the data is given in inclusive series, so very first thing what you are supposed to do is you have to convert it into an exclusive series. So that is what I have done over here. If you see, I have drawn a table for you which has 3 columns. In the left hand side, the very first column I have taken the marks, but these marks I have converted into an exclusive series. Now see how. Now if you see, this data is not in a very proper order. If we see, the marks has been starting from 46 to 50 and it's been ending from 11 to 15. That means we have to put it in the ascending order, and at the same time you have to convert it into an exclusive series. So we'll take it from the ascending order, that is we'll take the data from 11 to 15. Now to convert the inclusive series into an exclusive series, if you all remember, I've explained you before also that what you are supposed to do, you have to check the class interval. That is, if you check the first class interval or the last class interval, if you see, let's check the first class interval. If you see, the first class interval is 46 to 50 and second is 41 to 45. And I told you before also that what you are supposed to do is you need to deduct the first limit of the class interval, that is the first limit which is the 46, from the second class interval, that is the lower limit, that is 45. So if you deduct 46 from 45, you get 1. Same goes if you come with the end where you have 11 to 15 or 16 to 20. If you deduct 15 from 16, you get 1. Now to convert the inclusive series into exclusive, this 1, what we will be doing, from 1.5 we are going to deduct from the lower limit, and 0.5 we are going to add in the upper limit. So children, if we see this data, and first let's put it in an ascending order. So ascending goes with 11 to 15, then 16 to 20, then 21 25, then 26 to 30, 31 to 35, 36 to 40, 41 to 45, and 46 to 50. So if it is first one 11 to 15, so in 11 to 15 we have to do what? We have to deduct 0.5 from 11 and we have to add 0.5 in 15. So if we deduct 0.5 in 11, we get 10.5, and if we add 0.5 in 15, we get 15.5, right? Then if you see the next one, the similar thing we have done, that is 16 to 20. So we did what? We have deducted 0.5 from 16, we got 15.5, and we have added 0.5 in 20, we got 20.5. Similarly, the third one, again deduct 0.5 from 21, you get 20.5, add 0.5 in 25, you get 25.5. Similarly, the next 26, you deduct 0.5, you get 25.5, you add 0.5 in 30, you get 30.5. Then again From 31 you deduct 0.5, you get 30.5. 35 you add 0.5, 30.5. Then again from 36 you deduct 0.5, 35.5, and 40 you add, again you get 40.5. Then the next 41 you deduct 0.5, you get 40.5. In 45 you add 0.5, you get 45.5. And the last one, that is you deduct 0.5 from 46, you get 45.5, and you add 0.5 in 50, you get 50.5. Now children, can you see your inclusive series is converted into exclusive series? Now check it again. 10.5 to 15.5, then 15.5 to 20.5, 20.5 to 25.5, then 25.5 to 30.5, 30.5 to 35.5, and 35.5 to 40.5, and similarly 40.5 to 45.5, and 45.5 to 50.5. See how easily we are able to convert this inclusive series into an exclusive series. The only thing we have taken the difference, which was 1, and that 1 half of it is been deducted from the lower limit and half of it is been added to the upper limit. This we have done in all the class interval and we got it into an exclusive series. Next is frequency. Now be very alert over here. Maximum children, they do the mistake here only. Now if you have done it in an ascending order, then at the same time frequency also has to be in ascending order. That means if you have taken 10.5 and 15.5, that is 11 and 15 first, then the frequency will also be in ascending order. Now that is why what we have done. We have taken 7 to be as a frequency of 10.5 and 15.5, then 10 for 15.5, 20.5, then 13, then 26, then 35, then 22, then 11, and then 5 for 45.5 to 50.5. That means even our frequency is in ascending order now. Now easily you can calculate cumulative frequency, which already you people know. What we have done, 7 we have taken as 7, then 7 plus 10, we have added that 7 to the next frequency, we got 17. Then if you add this 17 to the next frequency, 13, you get 30. Then if you add this 30 to the next frequency, that is 26, you get 56. Then if you add 56 to the next frequency, that is 35, you get 91. And this 91 when added to the next frequency, 22, you get 113. And if it's 113 has been added to the next frequency 11, you get 124. 124 when added to 5 frequency, you get 129. So children, you got your cumulative frequency. And now our sigma f, that is our frequency, which is n, if we add it together we get 129. It is absolutely correct because our last cumulative frequency is also 129. Now we are going to put this into a formula. Our formula goes like this: m equals to size of n upon 2 item. So if we see n, our n is 129 upon 2 item, and if we divide 129 by 2, you get 64.5. Now what you have to do, you have to find the 64.5 in cumulative frequency. Remember, so if you see cumulative frequency, 64.5 comes in which figure? It comes in 91. When it comes in 91, that means, you remember I told you that your cumulative frequency or cumulative previous will be before the number which is 91. So that is 56. So I have put that cumulative frequency into a box for your convenience. So 56 is your cumulative frequency, just in front of 91 where our size of 64th item lies. 35 is our frequency. Again I put it in box so that it becomes easy for you. And in front of this our class interval is 30.5 to 35.5. So children, your L1 goes to be as 30.5. Now we'll put this into a formula. Already we have taken our CF is 56, our F is 35, our L1 is 30.5, and your I is 5, which is the difference between 35.5 if you minus 30.5, and you get 5. Now our formula goes like this: m equals to L1 plus n upon 2 minus CF upon F into I. So L1 is 30.5. N is 129 upon 2, your CF is minus 56, and your F is upon 35 into I is 5. So 30.5, if you deduct 129 from 2, that is you divide, you get 64.5 minus 56 upon 35 into 5. So M equals to 30.5 plus, if you deduct 56 from 64.5, you get 8.5 upon 35 into 5. So the m equals to 30.5 plus 1.2. So children, your median is 31, that is 30.5 plus 1.2 comes to 31.7. So this is how we can calculate median from the inclusive series. The only thing which we have to remember is to put the data into an ascending or descending order and then convert the inclusive series into an exclusive series, and then easily you can find the median.